Oh, sorry, I forgot to click the recording. But this is number 5. We need to expand it first, and then until we find this form, then we can just differentiate it. And then for point 2, it says that where the curve intersects at y-axis, it happens when x is 0. So we just put in the x is 0 to the normal equation, the first original one. Then we have the point. And then from here, when we put in x is 0, the gradient will be 5. Okay, so we just need to put it in, and this will be the equation. Now, number 3, find the set of values for x for which this function is an increasing function of x. Okay, so we need to find increasing means the gradient has to be bigger than 0, right? So we have this. Let's try to complete the square first. So we have 12 minus 6 minus 36 and 9. Okay, so there we go. Plus okay, equalities, so we find this and this. It's not equal to, so it's just more than 0, so it's an empty circle. And let's take a bit of like 0 here. For example, when x is 0, using this equation, when x is 0 means 0 minus 3 is correct, right? So we are going here. For this one, let's say that x is 3, then y will be 2, 3, also correct. So the range will be x less than 12. This will be the answer. Number 6, we have this equation px, where p is a positive constant. Show that the origin of the stationary point is a stationary point. Okay, origin means this. So this is the point. Let's differentiate this first. When x to px, when x is 0, the gradient will be 0, right? And this means it's a stationary point. When the derivative y over x is 0, it is a stationary point. Okay, right? So we we can say that yes, this is a stationary point, the origin. Now it asks to form an equation. Find the coordinates of the other stationary point in terms of P. Okay. We have this. The gradient is 0. It means we can do this plus 2p. Right. Then we can put in the original function. Okay, this is x. This is the y. If you put it into the original function again, we will have x will be this. Well, over here. X and u. Then it asks us for the nature of the equation. Nature of each of the stationary points. So we have two stationary points. This one and also this. For us to find the nature, we need to use the second derivative. So let's do this first. When 0.0, because it's positive means this is the minimum point. And then for this one, so this one is a max point. So it is minimum point of this and then maximum point find the set of values for P for which this curve has no stationary point. Okay, stationary point happen when this one. For us to not have this result, let's find the different derivative first. Okay, we don't want any stationary point, so the discriminant needs to be less than 0. Okay, then again, oops, not the circle yet. 0 and 3. What we want is this becomes less than 0. So let's take at the center here, for example, like p is 1. So yes, so over here, then the range will be this. That is for number 6.3.